Hi everyone, welcome to today's lecture. Today we are going to talk about Atterberg's limits. So we have three Atterberg's limits: liquid limit, plastic limit, and shrinkage limit. The experiments that we are doing are mainly for liquid limit and plastic limit. So these Atterberg limits technically are moisture content. So if you have a dry soil and if you mix it with water, it's going to become like a liquid, like a paste. And if you start like playing with it or let it set, it starts to dry out. The water content at which the soil is moving from a liquid state to plastic state, we call it liquid limit. And the moisture content that soil moves from plastic state to semi-solid, we call it plastic limit. And the moisture content that soil is moving from semi-solid to solid state, we call it shrinkage limit. So you need to know the definitions for liquid limit and plastic limit for this class. Also, there is a link to a video. It's always also on Canvas. Please watch the video to see the procedure. I'm going to cover the liquid limit first, and then I move on to the plastic limit. For liquid limit, what we need, it's this Casa Grande liquid limit device. It has a brass cup and it has a crank. We also need a bowl just to mix the soil, the dry soil with water. We need a spatula. We need a grooving tool, which is a standard ASTM grooving tool. And we need 3 cups. And those cups are measuring soil's moisture content. If you remember from soil class, moisture content is the ratio of the weight of the water over weight of the solid multiplied by 100. So what you need to do in the lab, you get the soil specimen. If it's wet, you measure it. So first you have to see how much your can weighs. Then you measure the can plus moist soil. So that the weight's going to be the can, the dry soil, and the water in it. Then you put the specimen with the can in the oven for 24 hours so it dries out. Then you weigh it again. So this new weight is going to be the mass of this dry soil and mass of the can. So if you subtract the mass of soil and moist soil, mass of the can and moist soil, and mass of the can and dry soil, what you get is the mass of the water. And also you can find the mass of dry soil by subtracting the weight of the can from the mass of the can and dry soil. So the ratio of the water, mass of the water divided by mass of the soil, dry soil, is going to give you the water content. So that's why we need the cans for this test. What we are going to do, we are going to mix the soil, dry soil, in the bowl with water. We don't want it to become too loose. We want it to become like a paste. Then we put this paste in the Casa Grande cup, the way that is shown in the picture here. Then we use a grooving tool to create a groove along the center line of the soil. And then we use this handle or crank to lift or raise the Casa Grande cup and release it. We are going to do this with the speed of 2 repetitions per second. And when you do this, the soil starts to move towards each other, the 2 parts. When it closes half an inch or 13 millimeters, then that's when we stop the test. And we count the blow counts, how many times you have to turn the crank for the soil to reach half an inch. And then you get a sample from this area, you put it in the can that you already weighed it, and you know how much it weighs. And then you weigh the can and soil, and you put it aside. Then what you do, you take the soil out of the cup, you clean the cup, the Casa Grande cup, and then you, based on the number that you got for the blow count, the number of cranks, then you decide if you should add water to the soil or you should just let the soil stay to like lose some water. What does that mean? That means if your blow counts are more than 35, that means your soil is too dry to reach each other. So you have to add more water to it. If your blow counts are less than 25, that means your 5 is too wet. That's why it gets close too quick. If you have a too wet soil, you can't add dry soil to it. That's not how we do it. We have to like play with it until the soil loses its moisture content. If it is your blow count is more than 35, then that means your soil is too dry, so you can add the water to it. So you repeat the test 3 times and you get 3 numbers. Then you plot the water content in percentage in arithmetic scale versus the number of blows in logarithmic scale. So this is a semi-log curve. Then you're adding the best curve fit. You want to have one number above 25, one number below 25 for sure. The moisture content corresponding to number of blows equal to 25 is the liquid limit. So if I asked you in the quiz or exam how you can find the liquid limit, you explain the Casa Grande cup, you explain how we perform the test, and then you explain that, okay, you draw the water content versus number of blows in a semi-log curve, and then the moisture content corresponding to number of blows equal to 25 is going to give you the liquid limit. Okay, so after we were done with the test, we have 3 specimens that we collected. We put it in the oven, we let it be for 24 hours, and after 24 hours, we take them out, we weigh them, and we put them in our Excel spreadsheet. Now I'm going to share the Excel spreadsheet to tell you guys how to do the analysis. Okay, so here we have the can ID. That's just how you name your cans. Liquid limit 1, liquid limit 2, liquid limit 3. Then you have the mass of the empty moisture can. So M1, this is the mass of the empty can. That's around like 15 grams. Then you have mass of the can and moist soil. So the difference between these two is the moist soil. And then after your soil dried out, then you weigh it again and you have the mass of the can and a dry soil. So if you subtract the mass of the can from M3, you're going to get the mass of the dry soil. And if you subtract the mass of the can and moist soil and the mass of the can and dry soil, you can get the mass of water. So the ratio here is giving you the water content. And that's what you need to find here in this row. You have the number of blows as well. Then you draw the graph, moisture content on the vertical axis, number of blows on the horizontal axis in a logarithmic scale. Then you draw the best curve fit, a straight line, and you find out what is the liquid limit corresponding to n equal to 25. And that moisture content is your liquid limit, and it should be in percentage. Awesome. So we are done with the liquid limit test. Now I'm going to talk about plastic limit test. So when you are opening this liquid limit and plastic limit data Excel spreadsheet, there are 2 sheets here, one for liquid limit and one for plastic limit. So pay attention to that. Okay, so I'm going to stop the share and share my lecture. Okay, so now, for the plastic limit, we mentioned that plastic limit is the moisture content in percent that the cohesive soil will change from plastic to semi-solid. So I should note here that we do the liquid limit test and plastic limit test for cohesive soil when they have fines in them. So what we need for this test is a bowl to mix the soil with water. We need a spatula to mix the soil. We need a cylinder for the water. We need a couple cans to get the moisture content of the soil. And we need this little bar to measure the diameter of the soil thread when we are rolling it on this glass plate. So what we do, we mix the soil with water, we roll into a ball, then we start rolling it. And after it rolls gets like a little thin, we put it on the glass and it starts rolling it on the glass. If your soil thread crumbles, when the diameter is 1/8 of an inch or 3.2 millimeters, which is the size of this little bar here, if it crumbles at that diameter, you take that crumbs and take it as a sample, put it in the can that you already weighted it, and you put it in the oven to dry out. If it breaks before you reach that diameter, that means your soil is too dry, so you have to add water. If you pass this diameter and your soil doesn't still crumb, crumble, then that means your soil is too wet. So you have to like kind of like play with it, like roll it and make the ball and flatten it so it loses moisture content, and then you repeat the test. So you do the test 2 or 3 times, and then you get the average of the water content of the samples, and the average is going to be your plastic limit. So for this test, I only have, if you look at the results, I only have 2 tests. So the can ID is plastic limit 1, plastic limit 2, and you have the mass of the empty can, you have the mass of the can with the moist soil, you have the mass of the can with dry soil, and plastic limit for each test is going to be the moisture content of the soil. You calculate that, it should be in percentage, and then your actual plastic limit is the average, and that's simply because we might have some errors, so we repeat the test a couple of times, and then we get the average. So what I want you guys to do is to watch the video that I posted on Canvas, and after that, do your analysis, write your memo, and post it on Canvas. Please let me know if you have any questions. Thank you, and have a great rest of the day.